Hello everyone. In this presentation, we are going to discuss about the role of aggregates and their characteristics in concrete mix design. Although cement often receives most of the attention in concrete, aggregates actually occupy 60 to 80% of the total volume of the concrete. The quality and characteristics of aggregates have a major influence on the strength, workability, durability, and economy of the concrete. Let us first understand what aggregates are. Aggregates are inert granular materials such as sand, gravel, and crushed stone. They form the skeleton of the concrete while the cement paste binds these particles together. They are not just fillers, instead, they provide strength, stability, and dimensional control to the concrete. Let us see why aggregates are so important. First, aggregates reduce the amount of cement paste required, making concrete more economical. Second, they provide a rigid framework that carries the compressive loads. Third, they reduce drying shrinkage and help control volume changes. Finally, they improve the workability of the fresh concrete, making it easier to mix, place, compact, and finish. They are classified in different ways. Based on particle size, we have fine aggregates and coarse aggregates. Fine aggregates are particles passing through 4.75 mm sieve, usually natural sand or crushed stone sand. They fill the voids between coarse aggregates and improve cohesion and surface finish. Coarse aggregates are particles retained on the 4.75 mm sieve, such as gravel or crushed rock. They form the main load bearing skeleton of the concrete and reduce the amount of cement paste required. Aggregates can also be classified according to their sources as natural, manufactured, lightweight, and heavyweight aggregates. Lightweight aggregates reduce the dead load of the structures, while heavyweight aggregates are used in special applications such as radiation shielding. Next, let us discuss the important characteristics of the aggregates. The first characteristic is grading, which means the distribution of different particle sizes in the aggregate mass. A well graded aggregate contains particles of different sizes that fit together efficiently. This reduces voids, improves workability, and decreases cement consumption. Poor grading increases voids and require more cement paste, making concrete more expensive. The second characteristic is particle shape and surface texture. Rounded aggregates improve workability because they require less water. Angular aggregates provide better bonding and higher strength but require more water and cement. Flaky and elongated aggregates should be avoided because they reduce workability and may weaken the concrete. The third characteristic is specific gravity and bulk modulus, bulk density. These properties are important for calculating mix proportions and determining whether the aggregate is suitable for normal weight, lightweight, or heavyweight concrete. Fourth characteristic is water absorption and moisture content. Before batching concrete, we must know the moisture condition of the aggregates. If aggregates contain free surface water, the effective water cement ratio increases, reducing concrete strength. If the aggregates are too dry, they absorb water from the mix and reduces workability. Therefore, moisture correction is always necessary during concrete mix design. Another important property is strength, toughness, and hardness. Strong aggregates help concrete resist compressive loads. Tough aggregates withstand impact, while hard aggregate resist abrasion, making them suitable for pavements and industrial floors. Aggregate should also possess good durability and soundness. They must resist weathering, climatic and chemical attack, and repeated wetting and drying. Clean aggregates free from clay, silt, and organic impurities ensure a strong bond with the cement paste and improve long-term durability of the concrete. Two practical concepts are also important in the mix design. The fineness modulus. It indicates the average particle size of the fine aggregates. For structural concrete, the usual acceptable range is 2.3 to 3.1. Sand that is too fine increases the water demand, while very coarse sand reduces workability. The maximum nominal size of the coarse aggregate also affects the concrete properties. Larger aggregates reduce water and cement requirements, making the mix more economical. However, smaller aggregates are preferred in heavily reinforced concrete because they can flow easily between the reinforcement bars. So to conclude, aggregates are not merely fillers. They occupy largest volume in concrete and influences the strength, workability, durability and cost of the concrete. Proper selection of aggregate, grading, size, shape, moisture condition and quality is essential for producing a durable and economical concrete mix. In short, good concrete begins with good aggregates. Thank you.